Thanks for that introduction. Ladies and gentlemen, thanks for the opportunity to allow me to talk about Radon. I'm at it over 25 years, and as my wife said to me last night, are you going to talk about your fourth child today? Because I have 3 kids and I'm constantly talking about Radon the whole time. As I said, we're in business since 1995. We deal with all the main types of installation of radon barriers. We also deal with all aspects of remediation in existing properties. We deal with many industries, with architects, engineers, design specifiers, main contractors, key people in the industry. I suppose that what I've seen in the last number of years is I've seen a huge change in the radon industry. When I started way back then, we were like, I suppose, the person who wasn't wanted on site. We were we caused problems on site because we are trying to go on site to install a radon barrier, and it might be in the way of the follow-on trades. Our view in our company is, in a new building, we want to stop radon getting into the building, and in an existing building with high radon levels, we need to get it out of the building. And as well as going through the remediation side of buildings with high radon levels, I'll also go through details that we come across on site that will tie it all in together. Richard has gone through earlier and Simon have gone through earlier the design detail of part C and D. I'm not going to drill too much into that because it's been done already. And most of you at this stage know the ins and outs of technical guidance C and D of radon. Just to give you a quick synopsis of what we do. We currently supply and install about 4,300 radon gas detectors in both commercial and domestic properties. Last year we carried out 346 radon gas remediation systems in properties with radon levels above the national guidance level of 200 becquerels and 300 becquerels for commercial properties. The highest level we have remediated has been 52,000 becquerels, and the lowest we have been asked to remediate has been 20, which is, now to be fair, outside on the open air, you get levels of that come up out of the ground, so you will never get it down to 0 with the best will in the world. On the commercial side, we have carried out remediation in 76 primary and secondary schools throughout the country, and that's an ongoing. The Department of Education are continuously testing their schools, especially with the upsurge in new schools that are currently being built at the moment. Again, with lots of different design details, and again, I'll just go through that later to give you an idea. Back in 2011, in England, we got a contract to test 2,450 houses for radon gas, and in that housing stock, only 45 houses were above the reference level of 200 becquerels. Compared to a scheme we did for a local authority in Ireland, we tested 100 houses, and 30 of those houses were above the reference level of 200 becquerels. As I said, I'm at this a long time, and I'm still learning every day, because there are buildings out there that can completely skew a result. For example, a pair of semi-detached houses on the same footprint can have 2 totally different readings between each house. So, as I said, we're learning the whole time. Now, as Simon earlier went through the technical guidance talking part C, referring to private houses of 200 becquerels and the workplace level of 300 becquerels. That might come down, the workplace might come down at some stage to closer to 200, but we have seen a big upsurge in testing of commercial properties and the workplace, especially in the last 2 years. Now, so as I said, most of you know what radon is, how it gets into the building. What we're finding here is we've all seen this drawing, how the radon gets in through the cracks, the walls, up through cavities, etc. This particular building has a full basement on it. If this basement is radon protected and waterproofed, the risk of radon getting into that building is very, very slim. What we've noticed in the last number of years is that houses we would have tested maybe 6 or 7 years ago are now being retested, and the levels in those houses are increasing because the house owner might have got the house insulated under the SEAI scheme, and we see a big increase in that. And I suppose what we feel is, you know, if a house is going for an NSCI grant to get it re-insulated, an allowance should be made to test that house as a matter of course, because all you're doing is, while you might be increasing the insulation value by replacing the windows and increasing the wall insulation, the paths of entry are still there into the property. You know, so what we try and do is we try and deal with that. And how you deal with that is you test the building first and foremost, and then if the levels come back high, then it can be remediated. Now, the map on here on the left-hand side, this is the map we were dealing with up to 2 or 3 years ago. And as you can see, there are many light shaded areas that were showing low back then. 2 years ago, this was brought up by the EPA, and all of a sudden, the uplift in radon inquiries went through the roof, to be fair, both in commercial and domestic properties. And I know Simon was saying that earlier, you know, that in a low radon area that a DPM will suffice, but the only problem is that, you know, that low area now might be high in a few years. And from our experience of installing radon barriers, we find that most clients will actually install the reinforced radon barrier as a precaution. And we're seeing that more and more. So literally, so from the testing point of view, what we do is, and again, there are other companies that do this service as well. I'm just speaking on behalf of ourselves, but across the board, other companies do it. So in a domestic scenario, we send out a radon test kit, and in that kit, you have two of these detectors, goes into the property for 3 months. It's sent back to ourselves. We send off the test to the lab. The results come back, and if that level is high, then we can go about remediating that property. And what we're finding is that, as I said, houses with high radon levels, it can vary. And even to go to a property housing or so, the design in them is very, very different. And it may take 1 or 2 attempts to get the radon levels down. If we go in and remediate a property, we'll install the extract system. We'll go back 2 weeks later and we'll retest that property. Now we retest with either, let's say, the 3-month detector, which is that one there, but we also use a digital monitor as well, which is very, very effective for giving a relatively quick result of what's happening inside the property. Sometimes we might be asked to test a domestic house, it might be a large house, and 2 detectors may not be sufficient to test the house. Sometimes they might use a digital monitor to test the whole house, so at least you might be able to get a gauge of where the radon levels are rising inside in the property. Now, as you can see, again, going back to technical guidance document C and D, every house has to have a sump, whether in a high or low area. What we find is if we go to a property that has a high level of radon and there's a sump in the property, sometimes what can happen is the location of this, sometimes it's not installed properly. Where Richard earlier this morning showed one installed with concrete blocks, sometimes they can be blocked, sometimes they can run back out. We've seen scenarios where they've been taken back out of the building again, and to activate those sumps may not be always successful. So what we'll do is we'll install the system in the property first, then we'll go back and we'll test. If it's a thing that the levels have not changed in the property, we'll bypass that system and we'll form a new system ourselves by coring in underneath the footprint or the floor slab of the house. We'll form our sump point inside in that void. We'll install our pipework, install our fan, and activate it. And it's very rarely we don't get the levels down. In my memory, I've one property above in County Clare that's sitting on the burn. It's a house that's built on a rock outcrop. The levels are in the thousands. I have 4 active systems in that property, and I have the levels down as far as 300. To get it down lower will take a lot more work. But to be fair, the client that's up there, they're happy with that level. In relation to extract systems, as I said, we do commercial and we do domestic properties as well. This system here, this is what we sometimes have to go through on a commercial building where it might be a ring beam around the building. We have to core through that. This is a school we did recently. We had to install 7 extract systems in the school. 6 were standard system, but this room, the floor slab here was 1.5 meters beneath the rest of the building. So in this case, we actually had to core into the classroom itself. We don't like doing it, but we had no choice. And we're currently monitoring this room specifically to make sure that the levels will be below 200 becquerels. We're fairly close to 200 at the moment. I'd say another few weeks we'll be below the 200. This will be a standard installation system where we core in beneath the footprint, as I said, the extract fan goes on. We always install a spur switch, an isolator spur switch in the system, because if, for example, the fan goes down in a couple of years, it's not going to knock out the electrical circuit that's connected on site. So at least, and if we need to repair it or maintain it, we can get at it. And it's all housed inside in this weatherproof box. And we have a gasket seal all around it, so that in the event if we have to go near a window, at least the radon is going to vent out the bottom here and it's going to disperse straight away. Because some local authority houses we would have to do, they could be terraced houses, so we have a very, very little wall space at the back. So this gasket seal makes a big difference. It just protects it instead of the radon venting. We all try and keep it away a meter from a window as best we can, but it's not always, it doesn't always work. In relation to radon protection, and I'll just jump into the membrane side now, because I think it works hand in hand. If we can't install the radon gas membrane properly, the knock-on effect is that when that building will be tested in a couple of years, we're going to have to go back in and to remediate it. We had a case of a school recently in North Cork where 10 years ago we installed 4 remediation systems in the existing school because the levels were quite high. The school employed a local builder to put an extension onto the school with a common corridor between the new extension and the old school. Building was tested after, and the levels inside the old school had gone up significantly over the 300 becquerels. And the reason being was that the builder had installed the radon barrier himself in the new building, wasn't installed properly. The radon gas was rising in that new extension and was just literally traveling above the corridor into the old building. So we had to go back in and activate the sump system that he had installed in that school, and we were able to get the levels back down. But I suppose the problem is trying to get the point across to people, like, and we see it on sites day in, day out. You have a manufacturer that has provided a product fit for purpose. It's designed into the new building. The builder, in theory, is supposed to build in accordance with the building regs and take into consideration the protection for that radon barrier. And in a lot of cases, what we find is that that's where it falls down realistically, because as I said, we install barriers every day of the week, and when we go to site, or we have to go back to site, we can see damage caused to the membrane by follow-on trades. And as I said, I'm at a long time, builders and developers, whatever, the focus still isn't on radon. I still don't think it's been taken seriously with some parties. We have people like the EPA that are pushing, building control, that are pushing, to get the radon issue dealt with in Ireland, but it's falling down in a lot of areas, I feel. Now, I might be open to interpretation on that, but it's what we see on site every day of the week. In relation to the barriers themselves, then, as you can see, this detail here, this detail would be a typical detail on a commercial building where an architect would have drawn up this detail to prevent radon inside to get into the building. Now, in theory, this looks perfect. It's a radon barrier coming along here under the footprint of the slab and up the side. In practice, this won't work on site, because what happens is this section has to go in first. It'll be left loose here for us or for another radon contractor to tie on back over here after. By the time we come back on site, the barrier here is absolutely destroyed. We're then trying to tell the builder, look, we have to get this repaired, and we're being told there's concrete coming out in the morning, has to get sorted, pour straight away. Or let's say there might be an assigned certifier on site saying that doesn't look like a detail that's in the admin cert, and we're trying to explain to the assigned certifier that that detail doesn't relate really to any element of an admin cert. What we do in that case then is, so we redesign. As I said, with our PI insurance, we can redesign it. So let's say this is our radon barrier here. We jump over to a liquid radon barrier that goes through here and drop back down to our deep sea detail outside here. And the advantage of that is that our radon barrier is protected at this level. There's no damage done to it down there. The sign certifier, because we can sign off on it, we are taking the responsibility for the installation of the radon barrier. Sometimes what can happen is that an engineer might have a query where we breach the structural bond here, but in most cases, once we explain what's happening, they can understand it. Again, this would be relating to local authority housing where, let's say, you might have stepped details in a house. So this is the lower slab on the lower house, and this is the upper slab in the upper house. And this area, the step, is always an area of concern. In a lot of cases, we will actually opt to waterproof this detail here and marry it in with radon on the lower level and radon on the upper level. And you're killing two birds with one stone. You're dealing with the issue of radon ingress in here and also water ingress. If we use an ordinary radon barrier here, the risk is that it can be damaged, and once it's damaged and torn, it's rendered useless. Whereas if we use a waterproof membrane along here that is radon certified, it'll seal that. So even if there's a hole, if it's damaged, the radon or the air cannot travel around. It's located at that point there. The radon barrier is the blue line down here, and when we bring out at the lower level, the waterproof membrane overlaps it here, so we have a full continuous membrane all the way through. So we're going from radon barrier to waterproof membrane, back up to radon barrier again. So you have the full suite. You have your delta, as I said, with moisture ingress and also radon as well. It's painted on, yes, it's a paint on. It depends on the thickness, and it depends on the, let's say, the smoothness of the concrete that goes on. I'll show you details of that in a second as I move on. This will be another detail here where, let's say, this will be standard concrete beam there. Floor finish is just, say, 50 mil above that there. Just above there's floor finish there. Normally what would happen is, in the old days, we would have tried to bring the barrier up around here and seal it on here, but you're very, very close to your finished floor screed there, and there's a risk that it will break there. We're using this liquid radon barrier with 6 years actually, and to be fair, it's taken us out a lot of wood, because in a lot of buildings, rising walls and rising blockwork would account for maybe 7 or 8% of the footprint of the building, and that's unprotected. So it's a solution we use. A lot of people would not use it, but we're happy to sign off on it, because at the end of the day, we can certify that the building has been protected from a radon gas point of view. Again, this detail here, right? We're doing some schools at the moment, and there's RC wall, precast walls being dropped down over all these bars. Now, to try and get a membrane across all that and seal around all those bars will be very, very difficult. So in this case, we have our reinforced radon barrier with our bitchin membrane, which is radon certified as well, going on to our RC wall here, which has the liquid radon membrane on there. That's going on 2 to 3 mil in thickness. It depends on how rough or how smooth the concrete is. The other advantage is actually it's a rust inhibitor as well, so at least it's not causing any damage to the bars. If there is an in situ concrete wall being cast down on top of that, there may be an issue with an engineer, and it depends on the engineer time, may have an issue. So what we've done in the past is we would bite into this wall, maybe 25 mil either side of the wall, so at least we're clamping down on the radon. Because a lot of people will say, oh, radon, if this concrete's thick enough, the radon won't get through it. To be fair, no one can stand up and say that, like, I don't think. This building here, and we're seeing a lot of these buildings that are going on at the moment, it's a modular type building that's been sat down on pads to support it. In the original drawing, the radon was supposed to go across, the radon barrier, was supposed to go across all these here. And but again, when you drop that building down on top of that, it'll be damaged. So that's the liquid radon. And again, we can certify all that aspect, or if another contract can do it, if the system like that goes in. But we have to get that across the line with the architect and with the design certifier at design stage. So if we're brought into design at early stage, we can actually help design a system that will work in the building as opposed to being dropped into the building after, when it's too late and we're trying to manipulate a radon system inside her. This is with full waterproof detail. This is a lift shaft that's going to be tied into RC walls coming off here. So in this case, this is both radon and waterproof protected. I think these products will be radon certified. And again, you have a full bund on this lift shaft, and the walls will be kicking off here. Will come back up to a radon level at that point. A lot of houses, a one-off house we're coming across at the moment, they are looking to maybe put a polished concrete floor in, or to put in an easy screed. And what happens in that case is the house will be built and that screed goes in after. But the problem is, if we install the radon at that point at an early stage, by the time, let's say, the installation is put down, that barrier will be destroyed. So in that case, what we do is we install strips on all the internal walls. The house is built as normal. We can come back in 4 months, 5 months time and seal onto all these walls to give it a full protection. For the likes of that system there, the way we operate is we don't take rolls on site. We pre-format all our membranes for the shape of the house, and we weld our system, and we also use our double-sided tape as well. It depends on the weather and it depends on the time of year as well. In the winter, we find the welding works a lot better. Commercial building where, again, precast walls are being dropped down onto it. That's actually a methane membranes, contaminated site with an air blanket system beneath it. And again, each bar has been individually. And to be fair, the designer in this scenario wanted it done this way. And in fairness, most times we will try and work with them to what they want within reason. Sometimes it doesn't always work. In this building here, this is a school where the architect, or the engineer, sorry, wanted a structural bond around the bar to get a structural bond onto the bar itself. So we've kept back 100 mil from each bar. Underneath is the liquid radon, which also acts as the primer for the bitumen there as well. So again, that's as close you can get to getting full protection. A very difficult design detail, to be fair. There's an awful lot of work in that. And I mean, best practice, if those walls were down and we could go straight through, it would simplify things and make things a lot easier from our point of view. Because the risk you have here is when this concrete's being poured and they're power screeding from this room to that room, they're pulling the screed straight across and they're damaging the top of the wall here. And these are the kind of things we try and get across at the start of the contract. May not always work. This house, there's a risk of water ingress coming through the RC wall at the back, and the engineer wanted it done this way so the water can travel beneath this membrane and this drainage system out in front of the property. We have our radon barrier outside in the front here, and a stepped DPC will be put in on top of that. A lot of builders will use the radon barrier as the DPC, but because it's not the thickness of a DPC, we always recommend that they use the proper DPC after that. This house is a split level house, so we have a radon barrier on the lower level, sealed to the inside the RC wall, and on the outside we have our radon and our waterproof membrane sealed here, and this is going to tie back in up to the upper level. So our radon level up here will be marrying onto this, which in turn will be sealed down here. Now we don't have continuity through that. For that to happen, you're into different detail where you'll have to put a waterproof membrane beneath the foundation of the wall to join the whole lot together. Now, this is an existing building with no radon protection inside it, and we're coming across a lot of these at the moment. So literally, the radon barrier is installed, the walls are primed, and a radon certified bitumen has been attached to the wall all around. Again, the risk you have is that if that's an internal wall, that wall in theory is unprotected. But again, it's when the house is finished and we test house after is when we realize if there is radon levels in it. When the floors are being dug out, we always recommend that the builder installs a radon sump in the middle of the building, takes the outside, so at least we have a provision to tie back into it after. Now that's just the product we use for liquid radon membrane. There's a test port and is certified for radon gas. These are details of scenarios where we go to site, just to give you an idea of what we had to deal with. This would be a commercial building where we had to go back to seal onto a floor, and this is what was ahead of us. So you can see zero protection. A difficult detail of steel mesh just thrown down on top of the radon barrier after it's installed. This would be a typical detail of 2 H-irons that are sealed with the earth rod coming up through it that we have to seal around. This detail, probably one of the worst ones we did actually, because you can see no thought was made for radon. Originally, this building all those walls were supposed to be flat. This is what we came back to, and you can see there's pipe going through all the internal walls. It's impossible, to be fair, to seal that 100% because every wall you see there and every corner has to be cut and sealed. Again, radon was an afterthought in this building, like, you know. Strip foundation, waterproof strip foundation. This would be a waterproof membrane that's gone into a strip foundation that will tie back onto the radon barrier up at an upper level. Again, another scenario where we go to site and you can see the plumber was put ahead of us, you know, no thought given for the installation of the radon barrier on this. We have to try and seal around every single one of those pipes. Again, cut every single wall. You know, a difficult job. Every commercial and domestic job we do, we automatically install a radon test kit in the property after, just to ensure that there is some level of protection, and it gives the customer and the end user peace of mind that the radon barrier has been installed to the best of our ability. Another difficult detail where, let's say, all the internal walls are up. Again, if we can get this to properly in advance, we can explain to the architect or the engineer or the client the best way to prepare the ground for us. Like very rough stone here, you know, no sand lying down on top of it. And the problem we have is we go to site and we say, sorry, Mr. Builder, we can't install that because it's not prepared properly. You know, he'll just pick up the phone and phone the next radon contractor he can get his hands on. And while the best will in the world, all the documentation and all the legislation is there, that's where it falls on. Another school above in Dublin, 860 of these bars we'd seal around. Like, these are very difficult jobs to do, like, you know. And we have, like, we're very tight frame to get this done. We have the main contractor saying this, we're pouring this floor slab in 2 weeks' time, you know. We have a job in Dublin at the moment, it's a pharmaceutical plant. We're installing radon barrier. And in this plant, they've employed a third-party verifier to ensure that what we have put in is 100%. And I won't lie, the detail he's going to is phenomenal. Yet, when he went off site, the concrete crew came on site. They started driving down rebar through all the membrane for their rounds for the screeds, and we said this can't happen. But unfortunately, the concrete contractor has more sway than us because they can't risk losing him or they'll fall behind on their pour dates. You know, so this is what we're up against. This would be a DPC. This actually is a monoflex DPC that actually complies with the building regs, and it marries onto the radon barrier. Would be good detail. The only risk you have is that you have to seal the DPC onto the radon barrier throughout the whole perimeter of the house. And sometimes that is a risky area because if you're doing this on a wet day, the tape won't stick, to be fair. It might well, but it won't stick, you know. So they're the kind of things that we try and take into consideration. Another difficult detail of radon barrier installed here, and that's where we would seal onto a lift shaft. Commercial building, again, that's what faces us. Sometimes you go on site, you just want to walk away from it because with the best will in the world, it's impossible to try and get a proper seal given the trades that come on after us. And it's like, you know, and we'll always say, any job we go to, we'll always say to the contractor, you know, if you do damage, let us know. An existing building, this house, so there's a new extension going on to an old house. So we've the new parts done first. They will be breaking through. So on the inside of that, we'll have to deal with that separately. But the risk will be that wall there. You know, it's internal. It's a 350 mil thick wall. There's a risk that radon can rise inside. But unfortunately, we won't know that until the house is built and it is tested. ICF houses, we are coming across a lot of these at the moment. And the installation of the radon, I'll finish up soon now. The installation of the radon barrier is kind of complicated. So what we try and do, some builders will actually try and bring the radon down underneath it, but you have a weak spot here then, and they'll try and dress the radon back up here, but it'll get damaged. So what we do is we bring a radon barrier across here. Where there's a break in the ICF, we actually take it straight through there, and we have our seal at that point. So from a radon point of view, the building is protected. From a structural point of view, it's not an issue because these Lego blocks, as we call them, are built down on top of each other. This house has, where the red line is there, it's a retaining wall coming up off this. So we have to waterproof all this, but again, we use our liquid radon all along here to protect that level first and foremost before the retaining wall was put up and it was tanked. ICF house with all those internal walls. Again, we have to go up over all these walls. I know I keep sounding like I'm complaining the whole time, but it's when I see this on site, it just gets difficult. And I suppose if there's more interaction with the architect and the client and design team beforehand, it makes life a lot easier. This is an interesting case. It's an ICF house that's built in an area where the levels of radon are about 6,000 becquerels coming up out of the ground. The owner has gone to enormous, I suppose, I won't say cost, but a lot of effort to protect it. So basically what we have is, we have a non-reinforced radon certified DPM underneath that full base. Down on top of that, so that's around the emitter. Down on top of that, we have protection boards sitting down on top of that. They've poured their concrete subfloor on top of that. Then we're going with a reinforced radon barrier on top of that again, and they're going to pour the final feed. So he's 3 levels of protection, and not only that, around the perimeter of the house, there's a 2-meter protection membrane going around the house, because in a lot of cases, while you might be keeping the radon out of the house internally, once you open the door and the levels are high enough coming up out of the ground, it can be drawn into the house, and that's why you might get levels up to 100, 150 becquerels inside the property. So that is it in a nutshell. Sorry, I rushed through it. I don't do these too often. Any information, you can get on to us at info@radonireland.com, and I said we'll help anyone as best we can, because at the end of the day, we want to get rid of radon. Okay, thank you.